any circles in the rectangle. First of all, identify their centers. So let's assume their centers are around here. So if you notice, we have right angle triangles. We have right angle triangle between this circle and this circle, joining their centers and taking the horizontal and vertical to intersect here. We have a right angle triangle. Doing the same thing here between these two circles, we have another right angle triangle. We know what the hypotenuse of these right angle triangles are, because they are simply just the radius of the circle, which is the distance from the center to any point of the circumference. So we have the center and the circumference of this circle. So the distance from here to this point is the radius of this circle. Then the same thing, the distance from here to here is the radius of this other circle. The same thing here, the distance from here to here is the radius of this circle, and the distance from here to here is the radius of this circle. And we know that since their diameters are 3, 4, 6, then the radius will be, this one will be 1.5, this one will be 2, this one is still 2, and this one will be 3, half of the diameters. So automatically we have a right angle triangle with a hypotenuse of 3.5. So let's make that 7/2, because 3.5 is 7, is 3.5, and 3.5 is 7/2. So we have this. Then we have this other one, which is having a hypotenuse of 5, 3 plus 2. This one is 1.5 plus 2. So we have these two triangles. If we can get this length, this horizontal length here, then they will definitely add up. This one being this, and this one being this, will definitely add up to AB. So what we just need is maybe some angles or the third sides of these two triangles to be able to get that. And since we don't have any possibility of knowing the angles there, or it might not be easy to get them arithmetically, then I think the better thing we should do is to find the third side. So since we have the hypotenuse, if we find this other side, then we can find the length that we need, and we can do that. So this will help. If we elongate this horizontal line from the center of this big circle to the end of the rectangle like this, we know that the distance or the length from here to here will be the radius of this big circle, which is 3. Then if we elongate a horizontal line from this point of this one's center to here, we know that the distance from here to here is going to be 2, because that's the radius of this small one. And since it's touching down here, we know that the distance from the center to the circumference that's touching down here of the rectangle is its radius, which is 2, and that will be the distance here. So we have a distance 3 and a distance 2, meaning that here is going to be 3 minus 2, which is 1. So we have this small distance here to be 1. Then it means that this side is 1 for this triangle. So we'll try to do the same kind of thing for this other one. So this is what we'll do. This other one has a distance here or a length that is this. So looking at what we have already, we have here to be 1. Can we get this other small part? Look at something. The horizontal line from here would pass through, or would be tangential. It would just touch this small circle. This same horizontal distance from this big one center would just touch the circumference of this small circle, because the radius of this big circle is 3, which is 3 down from the center down and 3 up from the center up, and 3 is exactly the same length of the diameter of this small circle. So definitely we know that since this is 3 and this is 3, then this line is going to just be tangential to this small circle. So what it means, or where it helps us, is that since this distance is 3, or this length is 3, and we know that the radius of this circle is 1.5, then this length from this center to this point, which is where this line passes through, which is the same length from this point to here, which is exactly what we are looking for, is going to be 1.5, which is the same radius of this circle. So we know that here is 1.5. So automatically we know that this length is going to be 1.5 plus 1. And 1.5 plus 1 is going to give us 2.5. And let's make that fraction. 2.5 should be 2.5, which is 5 over 2. So we have 2 right angle triangles, and we're looking for the remaining length, which will add up to give us EB. So that's simple. Pythagoras theorem will help us, and Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the squares of the other 2 sides, which are usually called opposite and adjacent. So we'll just find it for both of them. So since we have the hypotenuse and one of these other 2 sides, then the other one is going to be gotten by changing the subject of the formula. So let's see, the opposite is the subject of the formula, is the side we're looking for. Then if we take this one to the other side, then the subject of the formula would now look like this for opposites. So the square of the hypotenuse minus the square of the other side you have. So because any of them could be opposites or adjacent. So let's call these sides something. Let's call them, let's see x and y. So x is going to be equal to, or x squared is going to be equal to 7 over 2 squared minus 5 over 2 squared, and that will give us 49 over 4 minus 25 over 4, and that will give us 24 over 4, and that will give us 6. So it means that x is equal to square root of 6. Yes, because x squared will be 6, then x is square root of 6. Then we'll do the same for the other one. Let's do that here. So the other one has y squared equal to 5 squared minus 1 squared, and that will be 25 minus 1, which will give us 24. So y would then be equal to square root of 24. And square root of 24 is the same thing as square root of 4 times 6. And square root of 4, which is the same as square root of 4 times square root of 6. And square root of 4 is 2. Then square root of 6, since 6 is not a perfect square, so we'll just leave it in short form, 2 root 6. Then it means that AB will be the sum of these two lengths, x plus y. And that will be square root of 6 plus 2 square root of 6, which will be, so since they are having a common square root of 6, this one will be seen as 1 square root of 6. This is 2 square root of 6. So just like in algebra, for instance, 1a plus 2a, and that will give us 3a. So in this case, we have 3 square root of 6, and that's the length of AB.